Scientists theorized that 200 million years ago, the Earth's continents were joined together as one supercontinent, which they named Pangaea. Since then, the continents have shifted. In some places, they have moved apart. In other places, they have moved toward each other. Scientists refer to this theory as the theory of continental drift. The most obvious evidence to support this theory came from the shapes of the continents themselves. On a map, the shape of the eastern coast of South America appears to match the western coast of Africa, like two puzzle pieces. In Activity 5, students explore how the Earth's crust floats on the mantle and model the movement of continents over time. They observe the behavior of a solid floating on a liquid, complete a jigsaw puzzle of the continents, and infer that they were once joined. And students will also make a flip book to observe the movement of the continents over time. This activity will take 2 sessions. Session 1 is about 25 minutes, and Session 2 is about 40 minutes. The vocabulary introduced in this activity is continental drift and Pangaea. For this activity, from the kit, you will need a plastic bowl, butyl stearate, glue, styrofoam cup, and a small 1-ounce cup. In addition to the kit, you will need a world map, scissors, white paper, a measuring cup, stapler, ice water, room temperature tap water, and you will need paper towels. Also, make copies of Activity Sheet 5, Parts A and B for each student. Fill the plastic bowl half full with tap water and let it warm to room temperature. Place it at a centrally located demonstration table. Place the bottle of butyl stearate and 1 cup of ice water at the table as well. If your tap water does not get very cold, you may need to add a bit of ice to the water in the cup. Have the 1-ounce cup on hand for measuring butyl stearate. You will actually fill the 1-ounce cup about half full with the butyl stearate. This session begins with a demonstration of how a solid can float on a liquid. Teachers will be using a substance they may have never used before. Butyl stearate is a chemical lubricant used in making molds and is in many cosmetics. Teachers should read the warning label and caution the children of the hazards. When 1.5 tablespoons of butyl stearate is poured on room temperature water, it appears to be like oil in water. Now we are using a clear plastic container because it's easier to see the the butyl stearate floating. The properties of some liquids change when they become chilled. Let's see what happened when butyl stearate becomes chilled. Kathy, you have some ice water there. You want to just pour it gently in and around the butyl stearate. What do you observe?
Well, it looks like it went from a liquid to almost a solid, like a wax-like material.
Exactly. This is the model of the Earth's crust on the mantle. The mantle is composed of a hot, semi-liquid rock called magma. As the butyl stearate in this model is cooled, it becomes a solid and floats, just like the magma cools as it solidifies. Can you think of other substances, Kathy, that you have seen in both liquid and solid forms?
I've seen water in both liquid and solid forms, milk and cream turning into ice cream.
Okay. What causes substance to change from one form to another?
Well, when heat's taken away or when a substance is cooled, it will turn sometimes to a solid.
Okay, imagine that there is a heat source beneath the bowl, creating convection currents in the water. What do you think would happen to the solid at the top of the water?
I think it would probably, when we looked at our convection currents, maybe the heat rising might cause some of that motion, and some of our solid might start moving around.
Okay, we kind of saw that, didn't we, as we saw the butyl stearate break up and move. Scientists believe that the crust is moving slowly on the mantle. Discoveries support the evidence that the layer below the Earth's crust, the mantle, is semi-liquid. Heat from the outer core creates convection currents that can cause the crust to move. Therefore, if the crust moves, the oceans and continents move with it. The removal of butyl stearate can be done by just scooping it out of the water and placing it on a paper towel. Wash the bowl with warm, soapy water. Kathy, looking at the world map, suppose the continents were pieces of a jigsaw puzzle. Are there any pieces that might fit together just naturally?
Well, it looks like South America actually might fit right there if we put those two together. It looks like Australia might move into here and fit right here. Maybe North America down to right here. All
right, so there are some logical fits there. Students are given an activity sheet that will have the outline of the continents as they may have looked millions of years ago. The students will cut these pieces apart. Kathy, we've gotten them cut apart here. Do you recognize any of the continents?
Yes, North America, South America, Antarctica, Australia, Africa. But what about this India?
Well, you know, scientists believe that India might have been a separate continent at one time. Maybe it just moved in some way. What clues do you use when you're putting a jigsaw puzzle together?
I like to look at the shapes and put those together, and maybe the patterns and the coloring on the puzzle.
Well, why don't we turn these over, and let's try shape. So let's just kind of turn these over like this, and why don't you see if you can fit some of those shapes together? Looking at maybe some of the pattern.
Wow, that's kind of hard. I'm not really finding anything that fits together too well.
Not very well.
No.
Okay, so why don't we turn them back over and let's take a look at some patterns that we might match up. In Activity 3, students learn about some clues that scientists use to draw conclusions about the Earth's past. These clues include the type and the age of the rocks, the presence of glacial deposits and scratches, fossils found in the rocks. An additional clue was developed by looking at some rocks taken from various mountain chains. After we've turned the pieces over, Kathy, and let's take a look at the symbols on this key. What do the symbols on the key mean?
The rock of the same type, evidence of mountain chains, evidence of scratches, and same type of animal.
Okay, so why don't we use those keys to help us put the pieces together and see if we have a better fit?
Okay, well,
that's a perfect fit.
That's the type of rock and mountains. And this is the same type of fossil for the animal. There we go. Yeah, that fits pretty good. And then...
Okay, from the evidence scientists use, students conclude the continents may once have been joined together as one land mass, like the puzzle. Scientists believe that 200 million years ago, the continents were once one giant landmass, which was named Pangaea. This means all lands. Are the continents still pretty much the same shape, Kathy?
Pretty much.
They look the same, don't they? Considering how the world looks now, what do you think happened to Pangaea?
Well, it looks like it might have broken apart and moved.
Okay. Do you think that the pieces might be still moving?
Well, considering that they were moving that long ago, I would say they probably are still moving.
Okay, huge bodies of water in between. The movement of the continents is called continental drift. Scientists believe that the crust is moving about 5 centimeters or 2 inches a year. Activity Sheet 5, Part B, is a flip book that shows how scientists think the continents may have moved. Each student receives one and is directed to cut the squares along the dotted lines and stack them in chronological order. So Kathy, let's show how this is done.
Okay, I'm going to have this stacked from 200 million years all the way back to world at present on the bottom.
Okay, so that would be chronological order. I've done this with students quite often, and sometimes they're challenged because the flip book pages are small. So often I enlarge the copy about 10%, and that helps. A powerful stapler is useful because a less powerful one can leave exposed staples, and you don't want the exposed staples to scratch the children. The world at present is at the bottom. The stack is stapled on the left margin like a book.
Fanning it out just a little bit so that gives them a little...
Yeah, just that little bit of fan. Great. Okay. Now, Kathy, flip through the pages and demonstrate how this shows a visual image of the continents moving. Okay? Have students throw away the paper scraps, return scissors, stapler, and glue bottles to the storage area. Students can keep the Pangea pieces in their notebooks. Collect the flip books because they're going to be used in Activity 6. Guide the students through reading pages 6 through 7 in the Delta Science Reader.